Vygotskiy has developed a method of teaching students the art of modeling word problems. Our teachers use this method and see positive results. Teaching how to solve word problems is a bit problematic. If the students cannot solve word problems, they need to use models. However, the students who have difficulties with solving word problems also have difficulties with modeling. In order to resolve this situation, we introduce modeling using simple word problems. Particularly, in our school, we subdivide all one-step word problems into 4 logically homogeneous categories and teach separately each of them. Our students create models specific for each group. It includes pictorial representations, choice of parameters, and equations. After training, the students can successfully solve the challenging problems. Before students start learning modeling, they have to possess the following prerequisites: sufficient word problem vocabulary and knowledge of basic geometry of line segments and rectangles. These are 3 addition problems, and each of them requires a simple calculation, 7 plus 3. The first problem talks about the total of 2 values. The second problem compares values. And the third talks about the number that was increased over the course of the problem. There is different logic behind these 3 problems. The first problem we assign to a group of the problems dealing with parts and their total. Because the problem discusses independent parts and their total. The second problem belongs to the group of comparison. It discusses 2 independent parts comparing them. And the last problem deals with changing of the number of pop balloons. We assign this problem to the group of time problems. When it is one-step time problem, it is possible to treat it as part-part total, and treating such problem as a time problem is somewhat artificial. However, we ask the students to assign such problem to a time problem group, explaining them that in complex problems, such approach will be highly beneficial. Those are typical one-step subtraction problems. You can assign these problems to the 3 groups discussed earlier. In the first problem, there were balloons and then some of them popped. This problem is a time problem. The second problem deals with total. The third problem involves comparison. All these problems require the simple calculation, 10 minus 3. However, the logic behind the problems is completely different. The problems we have discussed so far fall into 3 categories: part-part total, comparison, particularly they belong to a subgroup that we call part-part difference. Problems with changing values belong to time problems group. Examples of proportion problems will be presented later. Part-part total problems involve 2 or more parts and their total. It can be that the students have to find total or one of the parts. There can be either 2 parts or several. The problems can require addition, subtraction, or both. The example demonstrates What models can be used with part-part-total problem? Explanation. These three sentences of the explanation explain the meaning of each number and the meaning of the value we have to find. In the explanation, the students underline keywords. The keywords will be used later in order to make parameters. The explanation allows the students to slow down and think deeply about the meaning of each number. Visual presentation allows to look at a problem from a different angle. In case of part-part-total problems, the picture always consists of two parallel lines. Along one line, the values of all parts are added. The second line represents the total of all the parts. Mathematical organizer. Organizer presents problem in a concise and clear form. In organizers, students use parameters that they identify when writing their explanations. This part-part-total problem has 3 parts and involves subtraction. Despite that, models are particularly the same as in the previous problem. Comparison via difference or part-part-difference problems. Problems involve 2 or more parts that are compared using their difference. In one-step problems, the pictorial models again have 2 parallel lines. However, the meaning is now different. First line represents the first value and second line represents the second value. Any of the parts or their difference can be unknown. These and the next problems exemplify the comparison via difference. In this problem, an unknown value is greater than the known by 3. And in this problem, 2 values are known, and the students need to find the difference between the values. Values can be compared not only using difference, but also using a quotient. If the problems involve 2 or more parts, which are compared using quotient, we call them part-part-quotient problems. This group of problems can require division or multiplication and involves only one type of unit. In this problem, the students need to find one of the parts, and this part is 3 times as big as the another. In this problem, the students also need to find one of the parts, but the unknown part is smaller than the another. If a comparison problem contains more than 2 parts, visual model has 3 or more lines. Logic of the problems stay the same. Time problems. Time problems involve values that are increasing or decreasing with time. Each one-step time problem has 3 keywords. 2 of the words are time markers, and the third word describes an event. It shows what is happening with the value. The first keyword can be one of the following: at first, at the beginning, or initially. We mark it as a time 1. The second time-related word can be one of the following: at the end, left, or now. We mark it as time 2. The time markers mark time before and after an event, and point on the value before and after the event. The third keyword is closely related to what is happening in a problem. Words like lost, cut, dropped, or went away manifest a reduction of a value. Words like born, received, found, or came mean the value is increased. In this time problem, the event that increased the number of popped balloons was the act of popping. It is shown in the picture that the value at time 1 is growing because the part with popped equals 3 is added. The mathematical model is similar to those in part-part difference problems. This is a time problem that involves reduction of a value. As you see, all the models here are still similar to the previous problem. These are part-part total and time problems solved by students of second grade. These are part-part difference and time problems written by Vygotskiy students. The homework was to create and solve a part-part difference problem that involves addition and time problem where what happened with value is unknown. After our students become fluent with the 3 types of problems, we introduced proportion problems. All the previous problems had only one type of units, balloons. Proportion problems cannot be created without involving second type of units, because by its nature, proportions involve 2 entities that are proportional to one another. The proportion problems can be illustrated using models of objects or by x-y graphs. For lower grades, we mostly use models of objects. Proportion problems with small numbers. We teach the students to write down proportion problems in 2 columns. Each column represents one type of units. In this example, one column summarizes the data that shows the number of days, and the second column lists data regarding balloons. The students also learn to read proportions. For example, in 1 day, 4 balloons. In 3 days, unknown number of balloons. Besides organizing data and making drawings, students learn how to correctly use ratio type units. Here is an example of students' work. These are examples of solving 2-step problems. This is one of the most challenging problems that the students solve within that curriculum. Using a visual model, the problem can be solved in just 1 step. Other way to solve the problem is using algebraic equations with 2 unknowns. Basically, when the students are able to solve and present their problem using models, we know that they know the models on the level of application. The approach allows us to reduce the number of parameters that vary. As Montessori's pink tower magically instills a concept of size, parameter variation in our case helps students to internalize the idea of modeling. Practice with homogeneous problems scaffolds students' progress toward logically non-homogeneous problems. Finally, fluency with presenting solutions to word problems considerably improves students' technical communication skills. To summarize, the novelty of this approach is in dividing one-step word problems into 4 groups according to their internal logic. The approach allows us to combine the best educational practices in teaching the art of modeling and solving problems. After taking our problem-solving course with any of our trained teachers, students are able to use models and solve highly challenging problems.